Algebra Unit 6, Lesson 2, Notes 2, Solving Systems of Equations by Substitution, Day 1. To solve a system of equations by substitution, first rearrange one of the equations so that it is equal to either x or y. Then, whatever you get for that, substitute it into the other equation. For example, if you solve for x, substitute the result into the other equation in place of x. Next, you're going to solve for the variable that's left. And when you get that answer, you're going to plug what you get, your result, into one of the two original equations to get the other value. It's best to use the substitution method when one or both of the equations are solved for a single variable. For example, x equals or y equals. If we take a look at letter A, we have y equals 2x and y equals 3x plus 2. Now, both my equations are solved for y. You only need one equation that's solved for either x or y. But they have both, so that's perfect. We don't have to do any work in the beginning. So I know that 2x equals y. So I can take this 2x and substitute it into my second equation instead of y. I know that y equals 2x, so instead of writing y, I'm going to write 2x. Equals, bring the rest down. Now you have a multi-step equation, so go ahead and solve for x. I'm going to subtract 3x from both sides. I get negative 1x equals 2. Divide by negative 1. X equals negative 2. Remember, in a system of equations, the solution is an ordered pair. So we have an x value, but we need the corresponding y value. So pick either equation, it doesn't matter which. I'm going to choose the first one. Y equals 2x. Make sure you rewrite it. And I'm going to take that negative 2 that we got for x, and I'm going to plug it in. 4x. So y equals 2 times, and let's plug that negative 2 in, y equals negative 4. And ordered pairs are x comma y. So parenthesis, negative 2 comma negative 4 is the solution. That means if I were to graph these equations like you did in the previous lesson, they would intersect at negative 2, negative 4. Okay. Let's take a look at letter B. This time that my equations are solved for x. So I'm going to take 5y minus 3 and plug it in or substitute it for x in the second equation. So instead of x, I will write 5y plus 3 and bring down the remainder of the equation equals 8 plus 10y. Let's go ahead and solve. I'm going to subtract 5y from both sides. I get 3 equals 8 plus 5y. Subtract 8. Negative 5 equals 5y. Divide by 5. Negative 1 equals y. Again, they're ordered pairs, so I need to figure out what x equals. I'm going to plug into the first equation. Doesn't matter which one you plug into again. X equals 5y plus 3. I'm going to take this negative 1 and plug it in for y into this equation. X equals 5 times negative 1 plus 3. Let's simplify. 5 times negative 1 is negative 5. Bring down the plus 3. X equals negative 2. So our solution is negative 2 comma negative 1. Let's take a look at C. Okay, letter C. We are solved for y in both of these. So I will take this 1/2 x plus 4 and substitute it in for the y in the second equation. So 1/2 x plus 4 equals negative 4x minus 5. Going to add 4x to both sides. 4x plus 1/2 x is 4.5 x. I'm going to convert that to a decimal to make life a little simpler. So 4.5x plus 4 equals -5. Subtract 4. 4.5x equals -9. Divide by 4.5. We get x equals -2. Pick an equation, doesn't matter which one. I'm going to use the second equation though, so I don't have to deal with a fraction again. Not that it matters, you'll get the same result. Y equals -4x minus 5. Going to take my x equals -2 and plug it in for x. Y equals -4 times -2 minus 5. Y equals 8 minus 5. Y equals 3. So the solution to this system is -2, 3. Okay, go ahead and do D on your own and flip to the back. Letter E. So this time, we do not have equations that are solved for either x or y. So I'm going to take a look at these two equations and figure out which one I want to solve for a variable. If you look at this second equation, we have 4y minus 4x equals 4. Now, they both have a 4, a coefficient in front of it, so not only would I have to move one of them to the other side, but I'd then have to divide to get x or y by itself. But if you look at this first equation, I don't have a coefficient to y, so that's, well, actually I do, the coefficient is 1, but I don't have a coefficient greater than 1 to this y, so I'm going to go ahead and solve this first equation for y. I could solve it for x, but again, because of that coefficient, I know I would eventually have to divide everything by that coefficient to get x by itself. So let's take the first equation, y plus 2 equals 3x minus 5, and I want to solve for y. I'm going to go ahead and subtract 2 from both sides. I get y equals 3x minus 7. Now I have an equation that is set equal to y. I can take what y represents and plug it into my second equation. So 4 times the quantity, 3x minus 7, make sure you put that in parentheses because it's 4 times all of that whole expression, 3x minus 7. Bring down the rest, minus 4x equals 4. Go ahead and solve this multi-step equation. Let's distribute. 12x minus 28 minus 4x equals 4. Combine your like terms. 12x minus 4x is 8x. 8x minus 28 equals 4. Add 28. We get 8x equals 32. Divide by 8. And we get x equals 4. Pick an equation to plug it into. Personally, I would choose this equation since I already have it solved for y nice and neatly. So y equals 3x minus 7. Y equals, I'm plugging in 4 for x. 3 times 4 minus 7. Y equals 12 minus 7. Y equals 5. So my solution is 4, 5. I think you can handle f and g on your own. You'll have to solve, again, one of those equations for either x or y, your choice. Let's jump to h. Okay, letter h. Now, I'm going to choose the second equation, and I'm going to get y by itself. So I'm going to first start by subtracting 2x. I get negative y equals negative 2x plus 7. Now there's an invisible negative 1 here, so I need to divide everything by negative 1. Y equals positive 2x minus 7. I'm going to take that expression, 2x minus 7, and plug it in for y into the first equation. I'm going to do this over on the right-hand side here, just for more space. So 3x plus 6 times the quantity of 2x minus 7, again it's in parentheses, equals 18. Distribute that 6. 3x plus 12x minus 42 equals 18. Combine your like terms. 15x minus 42 equals 18. Add 42. 15x equals 60. Divide by 15. X equals 4. And it doesn't matter which one you plug into. I think I'm going to use the one I solved for though. Y equals 2x minus 7. I'm plugging in 4 for x. Y equals 2 times 4 minus 7. Y equals 8 minus 7. Y equals 1. So the ordered pair is 4, 1. Let's do one more together. Let's do J. You can go ahead and do I on your own. Letter J. Again, it really doesn't matter which one you want to solve for x or y. I'm just going to choose the second one. I'll solve for y. Plus 6x to both sides. So we get 3y equals 6x minus 30. Divide everything by 3. Y equals 2x minus 10. I'm going to take this and plug it into now the first one, because I rearranged the second one. And we have 5x plus 2 times the quantity of 2x minus 10 equals 43. Distribute the 2. 5x plus 4x minus 20 equals 43. Combine like terms. 9x minus 20 equals 43. Add 20 to both sides. 9x equals 63. Divide by 9. X equals 7. Now that I have x, plug it into one of your equations. Again, I'm going to choose the one I already solved for. Y equals 2x minus 10. You could plug it into any equation. You should get the same answer so long as you've done your math correctly. Y equals 2 times 7 minus 10. Y equals, let's change that. 14 minus 10. Y equals 4. So the x value is 7, the y value is 4.